All right, so it is 10 o'clock. So we will get started. Let me pull up the PowerPoint. So on Wednesday, I mentioned at the very end of the session that we would probably just skip onto Friday's PowerPoint. I'm going to go back on that because I was re-looking over Friday's PowerPoint, and I don't think it's going to take us the whole time to do that. And I just want us to get more practice on unit conversion because I did get some emails about that. So I'm going to share Friday's PowerPoint, and I'm going to pull up question 3. Okay. And so we're going to work on a little more unit conversion here, doing question 3. And here we're going to look at density. And ethylene glycol is a molecule that's found in your antifreeze. It is a thing that makes antifreeze. And it has a density of 1.11 grams per milliliter. Now, what does that mean? What is a density? Well, a density is really just a way we can do unit conversion between weight and volume. So density allows us to convert between weight and volume, as long as we know the density of the substance. So for ethylene glycol, the density is we have 1.11 grams for every 1 milliliter of ethylene glycol. That's how much it weighs. That's what a density is. So I'm going to do A. I'm going to make a slight change to B, and then I'll do C. So let me make that change to B before I do A in case anybody just wants to go ahead and do B and C while I'm explaining A. B, I have kilograms right here. I'm going to say make that 0.932 liters. That'll make the problem a little more difficult. Anyways, A, how do we figure out the weight of 215 milliliters of ethylene glycol? All right, so let's start with our train tracks. We're going to start with the density. We have 1.11 grams of ethylene glycol for every 1 milliliter. And I want to know what's the weight in grams. So in my train tracks, I have milliliters on the bottom. I want to cancel out milliliters. And remember, with this system, if there's a unit at the bottom, to cancel it out, I need to put units at the top, the same unit. So I need to put milliliters at the top. How many milliliters do I put? Well, I want to know what is the weight of 215 milliliters. So 215 goes at the top. Milliliters cancel out, and my unit is left in grams, which is what the question's asking for. So I know I set up my problem right. Now you just multiply everything at the top together, divided by everything at the bottom. So it's 1.11 multiplied by 215 divided by 1, which means the weight of this amount of ethylene glycol is 239 grams, if I did my calculation right. And that is how you use density as a unit conversion. And that's how you can convert between a weight and a volume. So at this time, I'm going to give everybody a few minutes to see if you can do B and C using that idea of density. And for B, I want you to give me a weight given a liter of ethylene glycol. And C, I want you to give me a liter given a weight. So we're going to do that. As always, if you have questions or if you want to just check your answers, feel free to send me a chat. Otherwise, let's get calculating. All right, so there was a question for A if 238.7 would count. For right now, it would. We will talk in about 10 to 15 minutes why moving forward it won't and why you will need to round up. That has to do with Sig Figs. So we'll cover that in just a little bit when you round up and when you don't. We'll go over those rules. So it should be 239 when you round up, just because you want 3 sig figs. Like I said, we'll talk about that in a minute. What you round up to, when you decide to round up, all that good stuff. So it's been about 2.5 minutes, 3 minutes roughly. So I'm gonna slowly work through B in case you're sitting there and you're like, I still don't know quite what's going on, and that's fine. That's why we're here. So what is the weight in grams of 0.932 liters of ethylene glycol? All right, so B now. We start with our density again. 1.11 grams per 1 milliliter. Again, I want to cancel out milliliters because I want to be left in grams. So I know milliliters have to go at the top. The question is, how many milliliters go up at the top? Well, in our problem for B, our unit is not milliliters this time. It is liters. So I need to get into liters. And there's a couple ways you could do this. I'm just going to show you one way. Yeah, I'm just going to, the way I show you is not the only way. I'll say that. All right, so I want actually liters on the denominator and not milliliters. So I'm going to go back to the chart we looked at Wednesday, and I'll see for every 1,000 milliliters we have, that is 1 liter of solution. So 1,000 milliliters and 1 liter is the same amount. So I can do that conversion. So I just converted milliliters to liters. My milliliters cancel out, and now my density is in grams per liters. All right. So now that I'm in liters, I'm in grams per liters, I want to cancel out liters. So I'm going to put liters at the top, put 0.932. And now my liters cancel out, and I'm left in a unit of grams. That's what I wanted my final answer. And since that's the unit I'm left with, I know I set up my problem right. And so I multiply all the top together, divided by all the bottom. And the full answer you get is 1034.52 grams. Rounded, that should be 3 sig figs. Okay. 1.03 times 10 to the 1, 2, 3. Okay, so it should be, if we were counting sig figs, 1.03 times 10 to the 3 grams. Like I said, we will cover how I decided that later on today. How did I get 1,000 milliliters? Yes, so if you go back to the table, let me just see. Let me go back. I think it's on this PowerPoint. Yeah, so this table right here on the right will show you how to do conversions, right? So if I'm in liters, milliliters, 1 milliliter equals 0.001 liters. Another way to say that is 1,000 milliliters. If I multiply each side by 1,000, you get 1,000 milliliters equals 1 liter, right? So I just know in the back of my head, it's like burned in that 1,000 milliliters is 1 liter. You could also say 1 milliliter is 0.001 liter. But yeah, so it's using this table. Again, as a reminder, no matter what unit you're in, liters or grams, this is always the base unit of that. So liter, 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 and it'll tell you how to convert from decaliters, the centiliters, the milliliters, the microliters, so on and so forth. So when doing these problems, if you don't have these in the back of your head, make sure to refer to this table. All right, so we want to do C now. So now that you have B out there, I will give everybody, like, just in case you weren't quite sure what was going on, I'll give everybody like a minute or two to at least try to set up B. 2.2. Whoa, I just hit the wrong button. Sorry, everybody. Let me go back to where I was. All right, so for C, I'm going to do something a little weird that might not seem intuitive to you. It might not make sense, but let me explain it once I write it down. So for C, I'm going to actually reverse my density. I'm going to say for every 1 milliliter, there's 1.11 grams. And the reason I did that is because I want my final unit to be a volume. So I want my volume to be at the top of my density instead of my weight. So I have 1 milliliter over 1.11 grams this time, because that's what my final volume, or my final answer should be, a volume. All right. So let's just look back at the question. What is the volume in liters? Again, I'm in milliliters. I don't want to be in milliliters. I want to be in liters. So I'm going to do the same conversion I just did. There are 1,000 milliliters in 1 liter. Milliliters cancel out. All right. So now let's take a look at my unit. My unit is liters per gram. Right? So let's go back and look at the question. What is the volume in liters of 2.45 kilograms? So we have a problem there. I'm in grams of my density. I need to be in kilograms for my question. So I'm going to do a conversion where I go from grams to kilograms. And if we go back on our chart, we'll see, just like milliliters to liters, there are 1,000 grams in 1 kilogram, right? So my grams cancel out. Now my unit is liters per kilogram. That's my units right now that I'm working with. Perfect. I'm given a weight in kilograms, and I want to find out how many liters I have. So since kilograms on the bottom, I need to put a kilograms at the top. And I'll put my 2.45 because I want to cancel out kilograms. Now, you just multiply everything at the top divided by everything at the bottom. Our unit will be liters because that's the only unit that hasn't been crossed out yet. So that's when I know my answer is the unit. And then the actual answer will be 2.21. So those are some more unit conversions for you. And we will actually do more today as part of our Sig Fig calculations, because unit conversions are very prevalent in chemistry. But if there's any questions about what I did there, let me know. Or like I said, this is being recorded, so you can go back and rewatch that explanation. But I'll give people a minute. If you're unsure how I did something, I will try to explain it in a different way. So ask now. How did I get 2.21? All right, so let me get my calculator. So I'm gonna multiply everything on the top together. So 1 times 1 times 1,000 times 2.45. All right, if you multiply everything on the top together, you get 2,450. Now I'm gonna multiply everything on the bottom together. 1.11 times 1,000 times 1. So, oops, I did plus 1. 1.11 times 1,000 times 1. So that is 1,110. That's from the bottom. Then you take the top number divided by the bottom number, and that's 2.207. And then because of Sig Figs, I'm going to round to 2.21. So that's the actual math that I did to get 2.21. All right. Anything else? Or I will go on to our discussion on Sig Figs. Moving forward, and I was going to bring this up in Sig Figs, but I can say that as well. So for any calculation that we do in chemistry, you have to give the answer in the correct Sig Figs. If you don't, I will mark points off. So if on the test I gave you C and you gave me 2.207 back, that is technically wrong. You will get the majority of points. So you might get like 90% of the points, 80% of the points. You'll still get marked off for not rounding correctly. And I'll go into that in just a minute here about Sig Figs, but significant figures are very important when it comes to measurements and calculations and sciences. So we have to be aware of them. All right, so let me clear my drawings and go to the next PowerPoint. So screen share, new PowerPoint, 828, launch. All right, and there we go. Okay, so now we're on August 28th, which is today. And the rest of the time today, we're going to talk about Sig Figs. First off, what are significant figures? So when you do any measurement in a laboratory setting, the number of digits you can report are restricted by the type of instrument that you're using. Those of you taking the lab section, the first thing, like the first lab you do, is basically looking at glassware and figuring out the amount of Sig Figs. And so when scientists report numbers, they report numbers that they're only confident in. You can't just report all the numbers from a calculator because you aren't confident all those numbers are real. You can only report the numbers you're confident that are real, right? And so the numbers scientists feel are correct based on their instruments, we call these significant figures. And when you do calculations, you have to be aware of the amount of significant figures in all your calculations. So we're going to go over the rules for first just determining what is a significant figure and what is not a significant figure. So if you're ever looking at data, you can use these rules to determine what's significant and what's not. First rule, any number that is reported that's not a 0 is significant. So in my first example here, 28.03 and 0.00540. Not counting the zeros here, I'm just focusing on non-zero numbers. Any non-zero number you can assume is significant. So that's easy. Any non-zero is significant. Now, zeros are where all the rules come into play, right? Because there's a lot of rules to do with zeros. First off, any zero between non-zero numbers we are saying are significant. However, zeros to the left of a non-zero number, they are not significant. So 0.0032, when a researcher is reporting a number like that, what they're saying is that those first 3 zeros, they aren't sure if they're actually zeros or not. We can't be confident in that. I can be confident that this 3 and 2 are real measurements, but I can't be confident those zeros are. So we are not saying they're significant. So any 0 to the left of the first non-zero digit are not significant. However, any zeros to the right of a decimal point and to the right of a real number, they are significant. So if a researcher is reporting 45.000, they're saying with confidence, I know these 3 digits are 0. My instrument is saying these 3 digits are 0 and they are really 0. So they are significant. All right. Now, a 0 that is to the left of a decimal and also to the right of a real number is significant. So basically, if you're right of a real number and you're 0, you're going to be significant. And so when we are writing scientific notation, we have to be very confident of this, because let's take the number 1200, right? So these zeros may or may not be significant. And the reason I'm saying they may not be is because there's no decimal point. If there was a decimal point right there, you could be 100% certain that those 2 zeros are significant. But there is no decimal point there. So you are unsure. It's ambiguous to a scientific reader if the zeros are significant. So to get around this, we will use scientific notation. So let's say this 1200 is actually just has 2 significant figures, all right? So the way you would write it is 1.2 times 10 to the 3. And for those of you who it's been a long time how to write significant figures, I'll show you my method. So let's say our number is 1200, and I'm saying there's only 2 Sig Figs. The way to determine the power of 10 you put is I always put like a little decimal after the 0, and then I count 1, 2, 3. Now I'm between two digits. Those two digits are the only ones I want to report. So I do 1.2 because that's where my decimal stopped. And I made 3 arrows to get over to that place. So it's 1.2 times 10 to the 3. Now, what if there's 3 sig figs? I can do the same type of exercise. 1, 2, 3. And I can just report 1.20 because there's 3 sig figs times 10 to the 3. Now you can also do something where you do like, I just move my arrow over twice and I do 12.0 times 10 to the 2. Those are actually the same numbers, 1.20 times 10 to the 3 or 12.0 times 10 to the 2. It doesn't matter in all honesty, but I think convention is to have digit, decimal, then digits if you're going to use scientific notation. But it really doesn't matter. Now, if all 4 digits are significant, then you do 1.200 times 10 to the 3. Or right here, you can just put a decimal. And when you put the decimal, that is saying to your audience, these are significant. All right. Are there any questions about just determining what is and what isn't significant before we get into calculations using significant figures? All right, so I will clear my drawings. There we go. And let's go into calculations. How do you watch your sig figs and calculations? Multiplication and division is the easiest. When you do multiplication and division, there's a question. One second. Can you show more sig figs? We will be doing sig figs nothing but today. So we will get plenty of those. So I will go and do that in this example. All right. So multiplication and division. When you do multiplication and division, your answer should have the same amount of sig figs as whatever had the lowest amount of sig figs in it. So let's take a look at our first example, 1.052. So we have a 0 between 2 non-zero numbers, so that's significant. Then all non-zero numbers are significant. So there's 4 sig figs multiplied by something that has 5 sig figs. Now here's a 0 that's to the left of a real number. It is not between any real numbers. So this 0 is not significant. The 5 and 3 are, so that has 2 sig figs. So I'm multiplying 3 numbers, and one number has 2 sig figs. That's the lowest amount. So when you do your calculation, you can calculate it out to all the numbers. However, you have to report your number with the lowest amount of sig figs. Here, it's 4 versus 5 versus 2. So my answer only has 2 sig figs. So 6.7, and you'll round. So for rounding, what we're gonna say, and different people have different rules. If it's 4 or below, you round down. If it's 5 or above, you round up. We'll just round up 5s. Again, there's rules to go with that. If you learn somewhere else and it's a 5, I probably won't count you wrong if you round down a 5 because it's a toss-up. But 4, we're just going to say 4 below, round down, 5 or above, round up. All right. Same thing for our next problem. These zeros are between non-zero numbers. So in total, there's 5 sig figs. This 0 is to the right of a non-zero number. So it is significant. Remember, 0 to the right is significant. So I'm taking a number that's 5 sig figs divided by a number that's 3 sig figs. 3 is less than 5. My answer should only have 3 sig figs. So multiplication, division, super easy. Just count the number of sig figs in each number you're dealing with, report your answer to the smallest amount of sig figs. And when you do this rounding should always be your last step. When you cut the sig figs, that should always be your last step. So in the video, what I believe I said was, if it's like 6.75, you would, what did I say? I think it was like round down if it's an odd number, round up if it's an even number. Honestly, now that I think about it a little more, that's just arbitrary. So 5, we're just going to say round up for 5, just to keep it simple. On 2.0035, if there are zeros after the 3.5, are those sig figs? Yeah, so if I have 2.003500, those zeros are after the 5. So those zeros would be significant. 1, 2, 3, 4, 5, 6, 7. So that is 7 sig figs. Yep, so any zero to the right of a non-zero number is significant. Yeah, I think your textbook, and the previous version of the textbook, it said that for sig figs, if I remember right. That's why the slides said that originally, but yeah, it doesn't make much sense to me. It makes sense, but it's why bother when it's so insignificant. All right, next, multiplication and division. This one is harder, but not really once you get the idea behind it. What you do for multiplication and division is that you line up all the decimals in your numbers, and you just draw a line after the smallest amount. So by that I mean 0.07 has 2 digits. So you draw a line after everything with 2 digits. And you report your number with 2 numbers after the decimal. 5.9 minus 0.0221. There is 1 number after the decimal in 5.9. So I draw my line after 1 number. Now, my number is reported with 1 number after the decimal. So here you don't actually count sig figs. You just line up your decimals. Draw a line after the number with the shortest amount of decimals. And you report your number with those same amount of decimals. All right, let me get some, did I say multiplication or subtract? Yeah, I meant addition and subtraction. Okay, so I thought all decimals to the left of the first non-zero were insignificant. So how were there 7 sig figs in that example? Oh, you're talking about when I did 2.003500. That's because these zeros are between the 2 and the 3, so they are significant. If you're sandwiched between real numbers, you are significant. So 1, 2, 3, 4, 5, 6, 7. And these zeros are to the right of a non-zero, so they are significant. Yeah, addition and subtraction. Even if we need to round up, would we cut that off? I'm not quite sure what that means. So for example, I don't know quite what you're getting at, but like 5.679, we report only 2 sig figs. This 7 is greater than 5, so we round it up. All right. So you do rounding when you report your final answer. So 5.679 gets round up to 5.7. You shouldn't, and if you're doing addition and subtraction, you only round up at the very final step. So you write down all the numbers, then you draw your line, and then at the very end, you round up. All right. So it's one thing to hear me talk about this. It's another thing to do it. So let's do a little bit of practice. If the 2 in this example was a 5, 2 in this example was a 5. I'm not quite sure what you mean by that. I'm not sure what you're saying too, but let's get some practice. And 4.4. Oh, if that was a 5, yeah, you'd round up to 5.42. Okay. So it doesn't have to be 2.03 for the zeros to be significant. There can be, oh yeah, there can be more than 1 0, right? So 2.03, 2.003, 2.0300. 3 sig figs, 4 sig figs, 1, 2, 5 sig figs. Does the rounding you're doing right now for addition and subtraction apply for multiplication and division? Yeah, you will always do rounding at the very final step. But yeah, let's get to some examples, and hopefully that will either clear stuff up, or make it way harder for you. We'll see. So I will do the first problem with everybody, and then let you do B, C, and D, and see if we can get this. All right, so let me get the first sheet. All right, so A, we have, let me just see this. Yeah, so let's work through these problems and see if we can understand these examples. I think that might help. All right, so A, we have 1.7 times 10 to the 6 divided by 2.63 times 10 to the 5. All right, so we're doing if you remember your order of operations, I think it's like, I forget, like PMAS or something like that. I forget the acronym, but it's parentheses, multiplication, division, addition, subtraction. So we look at our first number, 1.7. This has 2 sig figs, the 1 and the 7. The times 10 to the 6, you never count that. You will never, if something says times 10 to the whatever, you never count those as sig figs. Those are just placeholder numbers. That's just saying this number is really big, but only the 1 and 7 are significant. Right, 2.63. That is 3 sig figs. So we are taking a number that is 2 sig figs divided by a number that's 3 sig figs. So for that, our answer should only have 2 sig figs. So I believe if you do this if you do this division, the answer on your calculator will be 44.71. Now, this number should have only 2 sig figs, but, and this is a big but, you do not round until the very last step. If you do your sig figs after every single calculation, you're going to get what is called a rounding error, and your digits might be off, or your answers might be off by a couple percentages. So your answer might be off by 2 to 3%. Now, that might not sound like a big deal to you, but let's say you're building a rocket ship to go to the moon. You don't want any calculation to be off by 2 to 3%, because that will cause a rocket ship not to go to the moon. So round at the very last step. So what I do is I have my number, 44.71. Next to it, I will write, this number has only 2 sig figs though. Only these numbers are significant. That's the only thing I care about, right? And so I'm going to do that, and I'm going to add it to 7.33, all right? Now, remember, for addition and subtraction, we draw the line after the most amount or the least amount of digits. Here, this might not seem intuitive based on what I just said. I'm going to draw the line after 44. And the reason for that is because only the 44 are significant. I'm going to keep the 7 and the 1 around just to do my calculation with. But they are not significant, so I'm not going to count them in my significant figures, right? So when I do this, my answer is 52.04. The 04 are to the right of my line. They are not significant. So now I'm going to do my rounding because I'm all out of mathematical operations. My answer is 52. So that's what I mean by rounding errors. You don't want to round while you're doing this. PEMDAS. Did I calculate that wrong? It's very possible that I calculated wrong. So let me pull up my calculator, also called Excel. So one sec. I'm getting to it. 1.7 times 10 to the power 6 divided by 2.63. Is it divided? 2.63 times 10 to... Oh, wow, that number's huge, isn't it? Whoopsies. I think I meant to put that as a multiplication sign. My bad, everybody. You're probably following along at home being like, what is going on? Yeah, that was supposed to be a multiplication sign. Otherwise, the number is like 600 trillion or something like that. Even bigger than that. My bad. There we go. Yeah, if you multiply it, you'll get 44.71. Okay, so I thought we only used the least amount of sig figs in multiplication and division. We do. So that's why I said 44.71 only has 2 sig figs. I'm going to write down the whole number because if I don't, I'm going to have rounding errors. And if I have rounding errors, I'm going to get the wrong answer. Here, it doesn't actually, well, does it? So let's just say I round. Let's say I was not listening to my own advice. And I said 1.7 times 10 to the 6 multiplied by 2.63 times 10 to the 5. I said that's 44.71, and I rounded that to 45. I just said, you know what? I'm not going to listen to Dr. Andrews. I'm just going to round when I want to round. And so I'm going to round that to 45. Then I'm going to add that to 7.33, and I'm going to add those together. So I'm going to draw my line, and I will get 52.33. Here, you'll actually get the same answer. You'll get 52. So no problem there. Let's just say, though, for the sake of argument, that instead of 7.33, this number was like 7.70. So 45 plus 7.70, and then you'll get 52.7 rounded up to, then that'll become 53. So you might get the wrong answer. Again, the answer won't be off by that much, but you should never round during a calculation, because if there's a lot of calculations you have to do over and over and over again, you will get that rounding error. So that's why I wrote 44.71 parentheses 2 sig figs. How do you do the multiplication for the numbers inside the parentheses? You should have a times 10 to the power button on your calculator. So you can do parenthesis 1.7 times 10 to the power of 6 in your calculator. It should be somewhere on your calculator. End parentheses multiplied by 2.63 times 10 to the power minus 5. Could we put the entire equation in the calculator and round it at the end? If you are good with parentheses and you are confident that you are putting it in right, then yes, you could. You have to use parentheses though. Otherwise, you will get the wrong answer. So make sure you're using your parentheses correctly. Why did you move the decimal? I got 4.471. It should be 44.71. I just redid the calculation. Let me just double check because I still have the calculation up. Yeah, it's 44.71. All right, so let's see if we can do these other problems. Now, I guess on Monday, we're going to pick up right here. It shouldn't take us much longer because I'll probably just pick up on question 2. But for the rest of the time, what I want you to do is try these out, and I will write down the correct answers. Okay, so got a bunch of questions, so I'm going to answer those in the order I got those. Do we have to round what's in the parentheses once we get the answer for what's in the parentheses? So for example, for A, when you do the multiplication for the parentheses, you get 44.71. You do not round that because you have more math to do. You write down how many sig figs you have next to it, but you don't round it. You only round at the very end. How did you get 52 again? You take 44.71, which is the answer from multiplying these two parentheses. You add that to 7.33, which I have written down. You get 52.04. You have a number that's only 2 sig figs, so nothing after the decimal. So your answer should have nothing after the decimal. Your answer is 52. How do we get 2 sig figs even though we had numbers after the decimal? Yeah, so this 7 and 1, they aren't real. That's why I wrote 2 sig figs. Those 7 and 1 aren't significant. They are there for calculation purposes only. They aren't significant, so I ignore them. This 2 sig figs is telling me only the 44 are significant. When I go to draw my line, ignore the 7 and the 1. Multiplication and division does not trump. So the question is, does multiplication and division trump the addition subtraction rule? No, it depends on the parentheses and how you do it. Every time you do a calculation, you have to know what type of calculation you're doing. Are you doing multiplication and division or addition and subtraction? And you follow the rules through each sort. Again, 44.71, that number only has 2 sig figs, only the 4 and the 4. I ignore everything else, and I'm just keeping it there so I don't get the wrong answer when I put it in my calculator. I got 4.471 also. Double check. I am very confident that I put it in right. I'm 100% certain I got that right because I'm looking at the calculation right now. I did. So the decimals only count if it's an entirely addition or subtraction equation. No, the decimals always count. Oh, let me rephrase that because the way I just said it is not correct. You have to be aware of how many sig figs you got. That's why in 44.71 I wrote 2 sig figs after it. If I would have wrote 3 sig figs, for example, if the number was 1.70 multiplied by 2.63, my answer would be 3 sig figs. And so I would write 3 sig figs next to it. So then my answer, that 7 would be significant. And so I would change where I would draw my line. I would write 44.71 plus 7.33. And if I said this is 3 sig figs, I would draw my line after the 7 because 1, 2, 3. Then I would add it 52.04. Oh, sorry, I did my line wrong. 52.04. My answer is 52.0. If that was the case, but that wasn't the case. Let me just reply to these last messages here. Um, Why isn't the 71 after? Because it's 1.7 multiplied by 2.63. 1.7 has 2 Sig Figs. 2.63 has 3 Sig Figs. Can you work on D before we go? So it is time. So if you need to go, feel free to go. I will go till 11 and put this whole recording up. Let me just see. Let me answer one quick message first. Yeah, so let me do D really quick. And again, all this work will be online. Also, we do have our supplemental instructor who put up that poll. He is also available for help on this, and I'm also available via emails. Okay, yes, but with addition and subtraction, isn't it the sig figs rather the number of after decimal? It says, so when we're in an equation without multiplication, then we just, so if you're addition and subtraction, you just focus on the number of decimals. If it's only addition and subtraction, yes. If it's multiplication and division, you count the number of sig figs. If you're mixing both, you have to take in both rules depending on what you're doing. But let me do D here real quick. Okay, so we have 3.14, 3 sig figs, multiplied by 2.4367, 5 sig figs. All right, so our answer should only have 3 sig figs from the parentheses. So I'm just going to double check my math. I'm going to plug that in my calculator right now. 3.14 multiplied by 2.4367. Your answer is, if I write down my whole calculator answer, 7.6512338. All right, but only 3 are significant, 3 sig figs. Minus 2.34. So 7 is significant, that's 1. 6 is significant, that's 2. 5 is significant, that's 3. Draw my line. And now I'm going to subtract by 2.34. 5.311238. All right. Only the numbers to the left of my line are significant. That's a 1, so I round down. So that should be 5.31 for D. Yeah, if it's a multi-step equation, you have to use each rule when you do that part of the equation. So in A, the first thing I did was multiplication. So I did the multiplication rule. Then the next part of the equation I did was addition. So I had to use the addition and subtraction rule. Every time you do a calculation, especially in multi-calculation problems where you have to do multiplications and addition and subtractions all throughout, you have to be aware of the Sig Fig rules for that part. All right, did I miss anything? Okay. When you say round down, do you mean leave it alone? Yeah, if you round down, just means like all these are basically, yeah, you don't change the number. So it's round down or round up. That's the phrasing I'm going to be using. Round up, you go a digit higher. Round down, you don't change anything. What if it's like C? Can we do addition and subtraction at the same time? C. So we still have 5 minutes, so I'll do C really quick here. So we have 9443 plus 4, whoopsies, 45 minus 9.9. So nothing after the decimal, nothing after the decimal, 1 after the decimal. My number that I report for C when I do addition and subtraction should have nothing after the decimal. So let's do that. 9443 plus 45 minus 9.9. So my answer, and I write down my calculator, is 9478.1. Now that 1 is not significant. I'm going to keep it because I have more calculations to do, but I'm going to make a note and I'm going to say only 4 sig figs. This number is only 9478.1. All right. Now my next calculation is taking this number and multiplying it by 8.1. 8.1 only has 2 sig figs. 2 sig figs are less than 4. So now I'm doing my multiplication and division rule where I'm taking 4 sig figs multiplied by 2 sig figs. So times 8.1 times 10 to the 6. So that will be, so when you do that, you get 2.61 times 10 to the 6. Now I need to only have 2 sig figs. So I need to move my decimal over to the left. So I'm going to move it over 1 place, 2 place, 3 place, 4 place. So when I do that, I get 7.677261 times 10 to the 10th. That 10 comes from, I originally have 6 here, and I move my decimal over 4 places, so I add 4 to it. 6 plus 4 equals 10. All right, this number should only have 2 sig figs, so 7 and the 6. Next to the 6, there's a 7, so I'm going to round up because it's 5 or greater. My final answer for C is 7.7 times 10 to the 10. All right, that's C. Do we always work with parentheses first? Yes, rules, order of operation says parentheses always go first. So if we input the whole equation in the calculator at once and round the end, would we get the same exact answer we would get if we had worked out what's in the parentheses first? You should. There's a big parenthesis or big caveat to what I just said. You need to make sure you are confident you are putting the numbers in the calculator right. If you are not sure about what you're doing with the parentheses, you will get the wrong answer. And I'll just say briefly what I mean by that. So in A, if you did A and you didn't put any parentheses into the calculator, your calculator will do 1.7 times 10 to the 6. Then it'll do divided by 2.63. Then it'll take this whole number and multiply it by 10 times 10 to the minus 5, because that's what you told it to do if you did not have parentheses, and you get the wrong answer. You have to make sure you are using parentheses. That's why I've said previously in videos, I never trust myself to get the parentheses right. I do it piece by piece, hit enter, write it down on a piece of paper. That's how I feel safe about doing it. If you feel safe about your parentheses in your calculator, you should get the same exact answer. So in B, do you get the sig figs at the end based on the lowest amount of sig figs in the parentheses? B, so I guess I'll do B super quick. Bonus lessons for everybody else, even though it's 11. I'll do this super quick. B, 568.99 minus 231.2 or 232.1. All right, so I draw my line after the 1. because there's one digit after parenthesis or after the decimal versus 2. So my answer should only have one number after parentheses. So when you do that calculation, I'm just going to trust I wrote it down right. 336.89. All right. This 9 is not significant, but I'm going to keep it there because I have more calculations to do. I don't want to round yet. So I'm just going to write, this only has 4 sig figs. The 3, the 6, and the 0.8. I'm going to take this, divide it by 5.3. So now I'm doing multiplication and division. 4 sig figs divided by something that is 2 sig figs. So my answer will only have 2 sig figs in it. And when you do that, if you put it the whole thing in your calculator, I believe you get 63.56. I round to 2 sig figs, so only the 6 and 3 are significant. And then it's a 5, so you round up to 64. All right, it's 11:02. My throat's getting a little scratchy from an hour talking. So we will on Monday, let me see. On Monday, we have some conversions, a little more conversion practice, and it will, and D for question 2 will have sig figs with it. So we'll have sig figs plus conversion. So we're going to do that briefly for question 2 and then move on. If you have questions about sig figs, let me know. Let Michael Nicholas know. He will be running our supplementary instruction. Basically, they're extra classes that all he will do is answer your questions and review the material and give you new questions to do. So I will supply him with new questions. And once he lets everybody know what time he's doing those, show up for those for extra practice. Email me. I can send you the links. If you want to have one-on-one conversations with this, we can do that. Otherwise, I will put this online. I'm going to go get a drink of water, and I wish everybody a good rest of your Friday. Take care.